Okay, so we're going to start with the periodic table. Just do a few here. So the periodic table is arranged according to atomic number, but we have some different parts of the periodic table that you should know. And the first is a period, which are the horizontal rows. And then there are groups or families, which are vertical columns on your periodic table. So if you look at your periodic table, which ours is still covered up. Once we have everyone take the quiz, then we can uncover it. But there's a stair-step line that is usually on it, and yours doesn't have it. And it would start right in between boron and aluminum. And it draws over, down, up, down, so it goes all the way across just as a stair-step line. And that kind of divides the periodic table between metals and nonmetals. Oh yeah, the one in your planner has a red line going down it. You can, if you want to draw it in on yours or not, but you can see the red stair-step line. And the left side of the stair-step line are the metals. And then on the right side are the nonmetals. And then metalloids are any of the elements that touch that stair-step line, except for aluminum is a metal. And it depends on which text you're looking at. Polonium and astatine is sometimes considered metalloid, sometimes not. So we're just going to say no because they're not always considered metalloids. So there are 6. It's boron, silicon, germanium, arsenic, antimony, and tellurium are your metalloids. Let's see. And then group 1. So group 1 is the far left column. They are called the alkali metals. And group 2 is called the alkaline earth metals. Now group 1, they're actually very soft metals. You could cut them with a knife even they're a metal, but they're very soft. Just cut them with a knife. And then group 2 is a lot more hard. So magnesium, you can rip it with your fingers. If you have a thin ribbon of magnesium, you don't have to have a scissors or anything, but it's still a lot harder than like sodium. Halogens are group 17. So the fluorine, chlorine, iodine, those are halogens. And then the noble gases are group 18. What's special about noble gases? Their orbitals are filled, their outer shell is filled, and so they're generally unreactive. Now, as the farther down you go in the group, the electrons get farther and farther away from the nucleus, and so it's easier for them to move and actually have a reaction. So there's a few reactions that occur with the noble gases that are farther down on the group, but generally unreactive. So this is just a picture. I think this is from your book, what it would look like. But metals are in the green, metalloids. See, your book considers these two as metalloids, but your planner doesn't. We're just going to say no, because I don't think the other class's textbook considers them either. And then the blue are the nonmetals. Now, one thing to notice, even though hydrogen is over on the left of the stair-step line, it is considered a nonmetal. Let's see, do we go through any of the properties of them? Nope. So, properties, where's my cursor? I cannot, oh, there it is. No. There we go. So metals, what are some properties of metals that you guys know? What state are they usually? Usually solid at room temperature, except for one metal is not. Mercury is a liquid. Nonmetals, they can be gases, they can be liquids, they can be solid. They can have all three states, be in either state at room temperature. And then metalloids are usually solid at room temperature. Metals are what's called malleable. Malleable means they're bendable. You can be able to shape them into different shapes. They're ductile, which means they can be pulled into thin wire. They have high luster. You guys know what high luster means? Shiny, yep. Non-metals are usually brittle, so when you try to cut them, they would break pretty easily. I guess metals are conductors, and non-metals would be non-conductors. And then metalloids are actually considered semiconductors, and metalloids share properties of both the metals and non-metals. Okay, so I already said that the periodic table is arranged according to atomic number. What is the atomic number? Atomic number, the little z in parentheses, it's represented by the letter Z. So if you see something that says Z equals 6, that means its atomic number is 6. And the atomic number is just the number of protons that are in the nucleus, and that determines its chemical identity, meaning it determines whether it's a carbon atom or an oxygen atom, the number of protons. The mass number is represented by the letter A. I don't know why they choose A, because atomic number starts with A. That would make more sense, but mass number is A. And that is equal to the number of neutrons and protons in the nucleus. So you add up the neutrons and protons. So on the bottom, you can't see it very well, but the symbol, we have a nuclear symbol to show the mass number and atomic number. We have A over Z, so the mass number over the atomic number, and then X would just be the element symbol, whatever element you're dealing with. So elements do have isotopes, and isotopes mean that the element has the same atomic number because they have to have the same number of protons to be the same element, but they can have different mass number. And so what would have to differ? Neutrons differ. And so you can have, like uranium here, there's uranium-235 and uranium-238. Now this symbol is called the hyphen notation, and sometimes it'd be written out as uranium, sometimes you could see just U-235, but the 235 and 238 would be its mass number. So protons plus neutrons. And then we already saw the nuclear notation, but this would be the nuclear notation for uranium-235 and 238, where we'd have the same atomic number, but the mass number would change. So tell me what the number of protons, neutrons, and electrons would be for each of these. Can you see this color here? What color would work better? Maybe just black. So I don't think you'll be able to see pink either. It's kind of hard. I'll just use black. So in this isotope, how many protons would there be? 8. How many electrons? Yep. 8 because it's neutral. We haven't talked about ions yet, but if it's neutral, it means our positive charges have to equal our negative charges. So protons equal the electrons, and then neutrons? 9. Good. Okay, how about here? Protons, 80, electrons, 80, and neutrons, 100? Good. How about this? This is still, what element is this? Mercury. So it's another isotope of mercury, so protons would be 80 again. Oops, I forgot the 1. And how about this element? Copper, 63, this isotope. How many protons? I can't read. 29? Is that what number it is on the periodic table? Because the periodic table, if you look at your periodic table, copper is element 29. That would be its atomic number. So how many electrons then? And neutrons? 34? Yep. Okay. Questions on solving those type of problems? Do you do this in physical science? 2 years ago? Okay. Let me just see what. Yes, we do want to talk about this. Okay, molecules are when we have two or more atoms in a definite arrangement held together by chemical forces. Basically, if you have, and we will talk about the difference between ionic and covalent bonds, but molecules really are only dealing with covalently bonded chemicals. The ionic bonded chemicals are called just compounds. Both of them are compounds. Molecules are compounds, but molecules are a special name for covalent bonds, which we'll see a little later in a different chapter. But there are diatomic atoms, and that means, what does di usually mean? Two. So two atoms bonded together. When it's in its free natural form, they're always, they are gases. They would be in just the two atoms, like N2, O2, Cl2, Br2. There are 7 of them. You need to know the 7. There's 2 different ways you can remember them. If you look on your periodic table, since there are 7 diatomic atoms, if you start at element number 7, which is nitrogen, and you draw a 7 on your periodic table, so it'd go nitrogen, oxygen, fluorine, and then chlorine, bromine, iodine, so there's your 7. That includes 6 of the 7. And then you have to remember that hydrogen, it would be your 7th one. So if you draw a 7 on your periodic table, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and then hydrogen is also a diatomic atom. Or if you like mnemonics instead, if you start with iodine, you can remember the mnemonic then go up to bromine, and then we'll go up and over. So I brought clay for our new house. So you can remember 2 different ways. I brought clay for our new house. So when we start doing problems with reaction and writing equations, whenever you see like fluorine gas is combined with oxygen gas, it's not just F and O added together, it'd be F2 plus O2. So whenever they're in their free elemental form as a gas, they would be diatomic. It's just something to always remember. Polyatomic would mean there's more than 2 atoms, like H2O has 3, NH4 has 5, so those are all considered polyatomic molecules. And this is just showing, these are called ball and stick models. We're showing the different molecules here. We will be doing a lab where you're going to build the molecules eventually. Okay, ions are single or groups of ions that have a net positive or negative charge. A cation has a positive charge. Now, you cannot lose protons. If you were to lose a proton, you have now changed the element. So the only thing that can be lost or gained is an electron. So when you have a positive charge, that means you have more positive charges than negative charges in that atom. So you have more protons than electrons, so you must have lost an electron. So sometimes that gets confusing. Where positive, usually you think of adding something to it. You're not adding, you're losing an electron, because now you have more protons than electrons. An anion is the negatively charged, and it is you've gained an electron. You have more electrons now than protons. Does that kind of make sense? Okay. How can you remember that a cation is positive, anion is negative?
They say anion reminds me of like an opposite, like I always think of proton base charge, like the main one, and then the electron is like a minor, like
Okay. If that works for you, that seems really confusing to me, but an usually means non, so negative. Yep. I always remember that cation has a T in it, and a T looks like a plus. So cation's a positive. Or you can use the prefix. And usually does mean non, like a, so you'd have a negative charge. That would work too. We have monatomic and polyatomic ions. What does mono mean? So you have one atom that has a charge. Polyatomic means we have multiple atoms that would have a charge. So these multiple atoms are held together by covalent bonds. And then all together they have lost or gained electrons. This is an ion chart you want to hold on to. 3, 4, 5. And if you look at this chart, in the periodic table part, those are all the monatomic ions. Oh yeah, I forgot to pick them up after. Thanks. And again, if you ever lose yours, they are right over here. Usually they're in with the periodic table, so the periodic tables and ion charts are kind of mixed together there. Did you give yours to Ben? Okay. And you will notice, and we'll talk about it, some of those transition metals in the middle, they have different charges that they can have. They can have like a +4 or a +2 charge. We'll talk about those. And then the box right on top, those are your polyatomic ions. And you'll notice that most of them are negative, except for the bottom right of the box has 2 positives. So actually most of the polyatomic ions that we'll see have a negative charge of some sort. We will start having ion quizzes. So over these, next week we'll have 3 of those. So maybe after we're done with notes, we'll talk about which ones and when it will be. Okay, one thing to notice with your periodic table of your ion chart, all of group 1, they have the same charge. They're all +1. All of group 2 are +2. And then if you go over to the nonmetal side, group 17, they're all -1. The halogens are 1, -1. Group 16, they are all -2. And then so forth. They kind of have a pattern. And why this happens, think about, I know we haven't talked about electrons in their outer shell, but sodium and group 1 would have 1 electron in its outer shell. And so is it easier, if they want to be stable with 8 electrons, is it easier to gain 7 or lose 1? Easier to lose 1. So they're going to just lose 1 electron and become +1. So that's what happens in all of group 2. Same with group 1. Group 2 would have 2 electrons in its outer shell. It's easier to lose 2. So it becomes a +2. When you get over to group 17, they have 7 electrons in their outer shell. It's easier to gain 1 than to lose 7. So they're becoming -1. So there's kind of a trend with those. Now, there will be a way when we look at names of electrons or names of the ions that you'll be able to see for the transition metals. Because look at iron. What's the difference between the name of those ions, do you see? Right, they have Roman numerals behind them. So there's iron 2, iron 3. That'll automatically tell you iron 2 has a 2+ charge, iron 3 has a 3+ charge. So now if we look at some isotopes again, notice that they have charges now. So how many protons are in this aluminum ion? How many protons? 13. How many electrons? Look at its charge. Right, it's 3 plus. So it's 3 protons more than electrons. So it'd be 10 electrons. And then how many neutrons? 14, right? You'd still subtract these two numbers here to get your number of neutrons. This is a 2 minus, yes. So how many protons here? 34. How many electrons? 36. We have 2 more electrons than protons. And how many neutrons? 34? No, 44. Yeah, 44, yeah. So really the only thing you have to look for the charge, see if it's neutral or not. Okay, so grab your clicker. You might want your periodic table out to answer these, or you could look at your ion chart because you should be able to tell which element's what. But which of these elements is most likely to be a good conductor of electricity? Who is 5? Well, I can look here. Let's see who's 5. Oh, okay. Is it going to bother you? That's the E, and the answer is E. Yes. Okay. What? Yeah, it's a metal. Which we have to think about which elements are good conductors, and the metals are good conductors. And so which one of those is a metal? Iron. It has to be on the left side of the stair-step line. Okay, an anion. What was an anion? Everyone's in. Answer is yes, A. They would have to have a negative charge. So they have to have a net negative. Remember, cation has a T, looks like positive. Anion would be negative, or the an prefix would usually be non or negative opposite. I can't read that. Huh? How many neutrons are there in an atom of lead whose mass number is 208? How many neutrons? And answer is yes, B. So you'd have to look up lead. Lead's atomic number is what? 82. So that's the number of protons. Then you would look, so the mass number is 208. That's the number of protons and neutrons. So you need to subtract those numbers, and you would get 126. Very good. Let's see, what's the next one? Give the number of protons, electrons, and neutrons in one atom of chlorine-37. How many protons, electrons, and neutrons are in chlorine-37? I don't think we'll have time for our quarter quiz, so we're going to skip it this week. Okay. Yeah. We had a test, too, this week. Sometimes weeks with tests we won't. We'll see. Who's number 4? Oh, it's sending. Okay, there you go. Answer is C. Yes. So you need to look up chlorine. Chlorine was element number 17, right? So that's the number of protons. It has no charge, so that means electrons are equal. So it has to be B or C, and they have to equal to 37. So protons and neutrons have to equal 37. Can you tell me about this oxide ion? Oh, yep, I forgot to push start. Okay, does it have more electrons or protons? Has more electrons. The answer is A. Yes. So it has 8 protons because oxygen is element number 8. And then it would have 2 more electrons. So you'd have to have 10 electrons. Which of these elements is chemically similar to potassium? So it would share chemical properties with potassium. Its reactivity would be the same. Which of these elements is chemically similar to potassium? Okay, elements in the same group have the same chemical properties, so you need to look down the group. And cesium is in the same group, so it have the same chemical properties. Okay, that's it. So that worksheet I handed out to you is due Monday. And we will talk about nomenclature on Monday. Oh, let's talk about, okay. Here's my ion sheet. Net charge would be like if it's a 2- charge, or is it if it's neutral, it'd be 0, and if it's like has 2 more electrons, it'd be 2-. Now remember, on the worksheet on the back side on the table, the symbol is once the nuclear symbol. So you need to put mass number. I know they're getting scooted. We're like, we need to slide over a little bit. Yeah. Maybe like right there. Maybe over just a little bit more.